There is the groovy basic structure here. I'm not going to go through this. This is really more for reference. If you want to dive into that, feel free to do that. What I am going to do now is jump to our final part around the syntax. And this really relates to what we call DSL2 and modularization. And we're going to go through this a couple of times in a couple of different ways to kind of see exactly how this works. So I'm going to start with a bit of a presentation on this and see what this looks like visually. Now, it should be pointed out here that DSL2 is essentially an evolution of Nextflow. From a practical perspective, it can sometimes look quite different, but it's more kind of much powerful in the terms of what you're able to do with it. But the underlying mechanisms are all the same. So we've still got processes, we've still got channels, everything behind the scenes is almost identical. It's just almost like a syntactic sugar on top of our pipelines. The key reason that it comes about is if you imagine our example like from before, like our hello world, or even our RNA-seq example, we are writing the pipeline from top to bottom. And we are defining, for example, index step, the process index. We were defining the quantification. But we had to essentially write that in a way where all of the code, firstly, was in the same script. So far, everything has been in a single script. And secondly, we kind of had to write it in a way where we couldn't reuse those components. What I mean by that is imagine that the index step, it actually defined, okay, it takes that as input. We couldn't write it in a generic way where we called index like 3 different times. If we wanted to use that index step many times, we would have to actually write it 3 times because it's kind of linked specifically with those channels. We'll see what this looks like. So this is a kind of a slight conceptual change in terms of the syntax, but you should see that it should be pretty easy to follow along and much more powerful, particularly when you start to run big pipelines. And as people start to scale this out to many different steps, sometimes 50, 60, 70 steps, it just becomes unmanageable having this into a single big file. So in a nutshell here, it's really an evolution of the syntax itself. It allows you to write those tasks, say, in a reusable way. It also allows you to do workflows which call workflows. So you can have workflows inside of workflows, which means that you can have what we call sub-workflows. And this makes it very powerful in terms of being able to combine things together as well. And it has a slightly more conciseness in terms of the way that it writes. It's very easy to migrate your code. In fact, we're going to migrate 2 scripts in the next hour or so, and we're going to see exactly what happened. Importantly, it doesn't change the data flow programming paradigm. So everything we've learned about everything so far is still 100% relevant as well. Okay, so the first thing, if you imagine that we look at our pipelines from before, and this is a basic one with 2 processes, notice here that we are really explicitly tying the process to the channel. So if I want to call the process foo, or if I want to call the process bar, I'm specifically stuck with having to do it via the foo channel. I can't just call process foo from somewhere else or from some other place. So what we've done with DSL2 is we've removed this dependency on explicitly defining the channel here. So what does that look like? You just simply remove it. So instead of saying the outputs are going into a channel or the inputs are coming from a channel, you just remove them. And by removing them in this sense, then you have to be able to obviously call the foo process and still define its inputs. So what does that look like? Well, you define, for example, exactly as you had before, process foo, process bar, without the into and the out, the into and the from sections here. And the next thing that we do is we can just call the whole workflow, essentially define this outside of that. So we can just say, in this case, foo doesn't have an input, so we can just say foo. And we can say that we can call bar, which is the second process here, by just saying channel of, and then this is our finals here. Now, what this means is that we're no longer explicitly linking those things together. So we could call foo from somewhere else, or we could have foo in a different script if we wanted it to. We could kind of define this in a whole bunch of different ways, and it gives us a lot more flexibility. It also splits out the 2 core parts of a pipeline. You're typically, when you're working on it, you're working on, say, a process, which might be an alignment step, or maybe you're writing a step for doing a particular kind of quantification. When you're doing that, you'll typically focus on the tool. like I'm working on salmon, for example, and I'm trying to figure out what's happening with that, and I'm writing that. And then you write the next step, and then you write the next step. That is one part of it, which is kind of like the process definition, the really thinking about your individual component. Then there's a second part of writing a pipeline, which is linking together. And with DSL2, we separate those two things out. And here you can see there's the definition of the process. And the second part, which is just linking those things together, goes inside of this workflow script here as well. There's some other things that we can do is we can reference the output of these processes here. So if, for example, we have process bar here, and then the output of bar is just again, it's still a channel here. And then what we can see is we can say, okay, if I want to view bar, I can just say bar.out, which is in this case, the single channel out, and view that as well. Other examples is that we can even give a name to that output. So we can kind of name the channel here. In this case, we're going to create an output channel called, in this case, called samples ban. And then we can say that, okay, this foo creates this and is able to reference that with a name itself. So that is another thing that can be useful here. We're going to go jump into a hands-on section here, but the other thing which is interesting here is the ability to remove the script all being in one file. So here you can define what we call modules. You can have multiple different files anywhere you want in your repository, and then you can call them, you can include them inside of your main workflow script. And there you can see that we are including the process foo from some file, and we're going to run the workflow where we're going to call that with everything else is the same. We're going to say our data, in this case, is a channel from path, and then we're going to say, okay, run foo with the data input here. Now, it's important to note, this is a bit more like you write with a function. And the input here, data, is still a channel. So again, all inputs and all outputs are still channels. And we are saying that foo has one input, one channel, and it is data, which is just this channel we've just created. So this here is the equivalent of before, where we had input path X from data. Kind of the equivalent way of writing that as well. You can include module multiple times. So again, this is the point I was saying before about if I've got the same component, maybe an alignment step, I want to then include that multiple times inside of that workflow and run that multiple times. This can be super useful when you want to, you can start to create like a catalog of your modules. And later on, Harshil is going to give us a demo of what that looks like in terms of NF Core. And they are now collecting, really, I think it's hundreds of modules so far using this approach that you can then call inside of your workflow and run in this way. There's also aliases. This is getting a little bit detailed for what we need to do, and parameters. But let's jump into a practical session and see what this looks like in practice. And we're going to start with our first Hello World example and move that into DSL2, see what that looks like. Okay, so I'm just going to okay, so we're going up to now up to section number 9. How can you distinguish between the two? How does Nextflow distinguish? Well, Nextflow is completely backwards compatible. So Nextflow will always be able to run whichever way that you want to write the pipeline. To do this, you can write, to specify DSL2 specifically, you can put this at the top of your workflow run. So I'm going to go into here and I'm just going to change I'm going to create a new pipeline here, a new file. I'm going to call this one, just going to save this as hello, instead of our hello world, I'm going to call this my hello2.nf and save that. And then I'm just going to place at the top of my screen here, this Nextflow.enable DSL2. Okay, so save that. Now we're good to go. Just clear this for you. So we're going to be saying Nextflow run, if you want to follow along here, hello2 on this one. And we're going to run. Now, quickly recapping, so this is not doing anything. Quickly recapping what original Hello World was doing here. Sorry, there's quite a few gaps in this pipeline. I'll try and remove this now. So our original Hello World had 2 processes, split letters and convert to upper. And each of those processes was essentially taking the string, splitting it into 2 files, and then printing the result for us. So very basic in that regard. We're going to recreate this now in DSL2 and see what this looks like. So I'm going along from the example here. We start with here, we're going to specify Nextflow.enable as DSL2, And then the first thing we're going to do is specify our inputs for this. So how this is going to work. So in terms of our process definition, we can have everything exactly the same in terms of the parameters. So if we had originally, we had params.greeting as hello world, all of this is exactly the same. So I can specify, put that in there. And the next one that I'm going to do now is take my original process here, which is split letters, paste it inside here. And this thing that you're going to see here, you can see the whole process. What we're simply going to do here is this is going to be removed here, and this is going to be removed here. And that's it. And that's the kind of the full deleting of that. How do we call this now, though? How does this actually do some work? How do we define this? Well, this is where we introduce the new workflow scope. And I'm going to say, instead of having process here for like the next process, we can introduce the workflow. This enables us to call this. By default, you can use it exactly in the same way as you would from a process. So you've got, again, the syntax of these curly brackets. You can give them a name. By default, the kind of, when you don't give it a name, it's the kind of the main one. So the one that you normally run. And here we can now call split letters, the process in this case, split letters, the process. And we want to give it an input. Now, we know split letters takes a single input. We can tell from this. So split letters takes a single input, which is a channel. And what it took before is this greetings channel. So I'm going to copy this and paste that inside here. If we run this now, you'll see that when we launch through there, it's going to launch through that pipeline, and everything else is the same. So again, split letters is run once, it's run there, and it's created our files. If we wanted to do that, we could also even take that and view that out. So we could say, for example, split letters is calling that, and then I think we can even say .out.view here for viewing the output. I believe it's like this. Or we can, I think we can assign it. Okay. What we can also do is, in the same way that you can say with a channel, you can set it and give it a name, we can also define here our output. So we could even say like our output file or our output channel here is equal to split letters.out here. And this one here, copy pasting errors here, save that. Now we're creating an output channel, which is calling split letters here. Wait, mess this up. Let me take the example here. So this, okay, let's just go back to what we had before. I think I've made some mistake. So original one here, going through. And then the next step we want to do is add the next process in here. So we've defined here just a single process so far, and I'm going to do the same as before. I'm going to take the second step, which is convert to upper, take that out. And in this case, we used reverse, but we're going to copy paste that. I'm going to paste it here above the section. And again, I'm just going to do the exact same thing in terms of removing it. So I'm going to remove the from letters section, and delete that, and I'm going to remove the into channel section. So in this case, it's pretty basic. We've just got a single input and a single output that's been created from those ones as well. Okay, how can we do this and how can we call it out? So the first thing that we need to do is call split letters again. So just confirm the syntax is right. We can run through that. And the next step we want to call is the next process, which is called convert to upper. So we can say here in the workflow section, convert to upper. I can just use my thing there. And the input of convert to upper is the output of split letters. So we can say split letters dot out. Now, if you remember, we also had a operator in there. So when this runs through like this is running through, but it's still going one of one here. And this is because if you remember that what split letters was creating was, it was a list of files. So however many characters we put in as our string will be however many kind of files we get out there. So what we can also do is we can introduce an operator here at the step. So we want to take the split letters.out and we want to say flatten. And we can call this now, and this is the same as before. So now we get to the two files which are running. And finally, if we wanted to view that, we could say, well, I want to view the convert to upper output. So convert to upper has run. Copy paste this, and I'm just going to say convert to upper.out. And I want to view that. Okay, let's give it the full name here. And you can see this will run through and we can see the output hello world exactly like we had before. Okay, if we want to see this now, and what happens if we had, for example, multiple outputs here? What if we wanted to reference them differently? So if I had here this process, in this case, imagine it was creating an output here, but it was also creating some value y. So there's two outputs in here. So here is a file that was doing this. Here is just taking out a value. If I want to reference those now, and I know it's no longer going to be useful for me to call this process because this is doing a view on two channels now. So I can specify exactly which output I have. And the way that you can do that is just with the reference here. So you can say output 0, which would be the first one, or output 1 if you wanted to view the second one. So this is a 0 index from there as well. And hopefully this should run through here and we should get the same result there. So even if we have two outputs as that, two channels as output, we run through here. Hopefully we can see this we're going to build this up with our RNA-seq example, which should hopefully make a little bit more sense for you as you're running there. Another thing to consider is that so far when we're running this workflow, we're running that kind of running from top to bottom. So we're kind of saying, okay, we want to run here and it's just going to run this workflow section. But you can also define inside of the workflow section its own inputs and its own outputs. And this can become really important if you want to call this workflow or sub-workflow in this case by another workflow. And to do that, you can define it by giving it a name. We're going to call this one pipeline, for example, my pipeline that I've got here. This section can all stay the same, except what we're going to do now is we're going to specify an input here. And the way that we do this, we say take. This is an input to the pipeline, a little bit like the input to a process. In this case, we have our greetings channel. And then the next part we're going to section is the main section, which is everything we've just had from before. And then you can even, if you wish to, you can even specify what that workflow outputs. So you can say emit. And then this is, again, a channel. All of this is still channels. So the workflow itself takes a channel and emits a channel, but it allows you to kind of combine these things together and to run them. So hopefully if we launch through here, we can see that we can run through this. And we can also call this pipeline now as well. So you can call this workflow. So we can define when we run this through to do that. I think when we run through here. So when we give it a name like this, imagine if you had like, I want to run my pipeline here. And I've got a copy of it, a copy of that one. And I want to now run that. I got another workflow. It might be a different way of running the pipeline. It might be a different combination of modules that you're putting together. But if you have here, this enables you to specify exactly which workflow that you wish to run. So by default, if you give it no name, it's the default one to run. So that would be like the default. I can give these names and then specify which one that I want to call. And I think if we go through here and run this again, we don't have it specified here. If you go to the documentation, you can see where this is listed. So this is under workflow. And we are specifying this implicit workflow that we have. So when you specify entry here, this is allowing you to run different workflows. So if we want to go here, we say, actually, I really want to run my pipeline 2. And I can say entry, my pipeline 2. Say, run that. And it allows you to have this kind of, almost not switching, but like really selection of what you want. Okay, so my pipeline 2 declares 1 input channel, but 0 is specified. To check this out, I think we may need to look at exactly how we're doing this. Greetings channel. Okay. So we've gone through here the basics definition here of the processes, again, removing that syntax and removing that out. We've seen how we can specify different outputs on terms of this, in terms of how we can split this up, workflow definition, how you can do this as well. If you wish to access here workflow parameters, so this is where you want to say, I want to access specifically my params.greeting here. You can access them using this params greeting within the workflow definition as well. And if you want to specify here, if you want to specify the inputs or outputs of these pipelines, you can, of these workflows, you can say take, and you can also use emit here. And this is really the output of that as well. That's really the main parts of the kind of core changes to the DSL itself. So this is the main changes, is say splitting off, removing those channels, and then defining the workflow outside of the processes. The other part, the other kind of key part to it is the modularization of it. And the modularization allows you to pull in files from different locations. So in this case, we could define, for example, split letters and convert to upper in different files. So we can go through this together as well. So imagine that we wanted to take here split letters, and we wanted to place this into a different file. So I'm just going to cut this out and create a new file here. You could call this whatever you want. I'm just going to call it splits.nf here. So let's save this here as split.nf. Save that. And I can paste now inside here the process definition. Now, when we import this, it's going to look for the name. So you can you can put multiple different processes in here. You can link them all together. Sometimes it's better to put one, depending on how you want to structure your workflows or structure your repositories more. In this case, I'm just going to put a single one inside here. So that becomes in there. And then when we go to hello and we wish to now import this, the way that we can do this is we say import that process itself. The example that we want to do here is to pull that in. We would say here, we say include, and then we can give the name of the process that we want to include. So in our case, we wanted to include split letters. And then the next part we want to do, we're going to say from where it comes from. So in our case, from dot slash, what do we call it? Split dot nf. This should be specified as a string. And that's it. That's really how you're able to specify and kind of split up your pipeline across multiple different files and run that through there. I think it's best now if we want to kind of see the power of this and how we can kind of see it, how it's used in a kind of, say, production setting, and kind of why this is so important. And I'm going to pass it over to Harshil, who's going to give us a quick demo on what it looks like for NF Core and what it looks like when you can create pipelines that have many different steps, and each of those steps can be modularized and split up, and really the kind of community effort to build out modules using this approach. So I'll pass it over to you, Harshil, and you can give a demo of what that looks like.
I thought it'd be nice to maybe give a brief introduction into what NF Core is for those of you that don't know. So NF Core is actually a collection, a curated set of pipelines that are built using Nextflow. And so we're quite tightly integrated with the Nextflow community, and we always have been from the very beginning. And that's kind of been the power of NF Core in itself. So we have about 50 odd pipelines that are used all over the world, you know, in various settings on different infrastructures for different bits of analysis. So there's 50 viral analysis. Most of them are sort of genomics focused, but we are fanning out. We've got an image analysis pipeline, quite a few proteomics ones, and so on. And so traditionally, we obviously started off using DSL1 as well, but then when Paolo announced that DSL2 would be coming out, it piqued our interest because we've got 50 pipelines. We would like to share functionality. There's no point in having one pipeline using one version of a module, another one using another one. And so it took a process for us to come up with some guidelines, some best practices in order to develop these modules, because you can imagine the unit of a Nextflow pipeline is just a single process, right? Because that process does some bit of work in the context of your workflow, and then it passes on to another process, and then you might do some manipulation in between with channels and operators, but then that's generally the idea. You stitch a pipeline together by combining processes. And so the idea for us, it started a couple of years ago, and we've had various iterations, improvements. I mean, this repo here called NF Core Modules was our first attempt at doing this and trying to collect and have a central repository for modules. And it's really just, it's taken off, and it always surprises me how, you know, when you do things like this in a community setting, how useful they can be. So now we've got over 100 contributors that have contributed. So you can imagine it a bit like the Bioconda of Nextflow modules, right? So with Bioconda, you go in, you add a package, you can update a package, and everything is done automatically, and then it immediately becomes available to the community. So this is kind of the approach that we were going for with this. And the big advantage, obviously, also is that these modules now can be used not only by the NF Core community, but anyone in the Nextflow community. And so now we've amassed about 400 modules here for a lot of your common tools. So if we look at one, for example, I don't know, if we pick SAMtools sort, maybe everyone knows SAMtools. I guess you guys probably know SAMtools quite well as well, because it came from that neck of the woods, I believe. So yeah, so if we look at SAMtools sort, we've got a main script. And this is that unit of work I was telling you. So what we have is a very simple process definition, which you guys will eventually be writing yourselves. But we've got a tag. We've got this concept of a meta map, which is essentially a map containing all of the sample information you need, including this ID, which would be your sample ID. And that really allows us to generalize using these modules in different pipelines, because every pipeline can have its own version of this meta map. As long as there are some very key components that are common, then it just works. And so we've got this meta ID, we've got this label, which Evan will probably go into regarding configuration. This allows us to set some default sensible configuration options for the module. And then we've got these container definitions, and these containers are coming from biocontainers. If you don't know what biocontainers are essentially Docker containers for Bioconda packages. And so they're very useful. They're open source. It's all available out there. So we're essentially just reusing what the community is already creating for us. So once a Bioconda package gets updated, or a new package gets updated, they immediately become available as Docker containers. There's also a Singularity mirror as well. So this saves having, if you're using Singularity, it saves having to convert the Docker image to a Singularity. But then you've got your standard fields, like Evan has gone through. You've got some sort of input, which in this case is a BAM file, and you've got an output, which is also from SAMtools sort, it would be a BAM file as well. And in order to keep these as flexible as possible, we've got some options that allow us to configure the command line options to, say, SAMtools sort coming from a configuration file. And this really allows developers to use sort of a vanilla version of SAMtools sort, or to add their own arguments and really customize the behavior of the module. So they can also rename based on a particular sample they want. It doesn't have to be, I don't know, test.bam. They can do test.sorted.bam or test.sorted twice.bam. It can be whatever they want. So that's generally the idea behind what a simple module looks like. In terms of contributing, it's really just, we've built a massive tool set for this now, based on various learnings. I mean, I started working on this ages ago and pushed a lot of this out before, and since it's developed quite a bit, but we've got contributors coming. So this is a pull request that was recently merged for this GATK module, for example. And this particular contributor's added a module, which again looks quite tidy. This is the same sort of syntax that we're using consistently. We've got linting tools to check this, some sort of information about the module. And to add to that, what we also have, and really what is the power of this, are unit tests. So this is another layer. I won't go into much detail, but what it essentially allows us to do is using very small minimal test data set is actually to test that this module works and runs whenever someone creates a pull request. And so that way we can constantly know what's working and how it's working. The package we've developed is NF-Core tools. You can install it via pip or Conda, whatever you want. Like I mentioned, we've got a whole heap of commands that you can use to maintain these modules. These commands essentially just talk to NF-Core modules and allow you to do various things. I'll give you a quick example in a second. There's various documentation about adding a new module and terminology and all sorts of other stuff, design decisions. I gave a talk about this not so long ago. So there's documentation available on the NF-Core website. I'll put these in the chat in a second. This is the biocontainers repository. But to show you quite simply, so if I've got NF-Core tools installed on my path, there's a bunch of commands that we can use to install these modules from the repo. So what I can do is NF-Core modules store. I think I've already got SAMTools sort installed in this module. So let's just pick another random one. Let's try and pick this one that's just been added actually. So if we go install, and then it asks you for a tool name. So we've got GATK. It's the demo curse. Oh, it's GATK4. And that's literally it. So you can install the module, and then all you have to do is just then include it in the context of how you want to run it. All of this is tracked. So if I do git status, you can see that we've added a new module at this standard path, and there's a hash in this modules.json that's been updated, and that's essentially our way of tracking the versions that we're installing within the repository for reproducibility. But yeah, like I said, there's a whole heap of commands and stuff. I'll put some documentation in here. I guess the key message here is that with this new modularity with DSL2, sharing really is at the forefront of implementing these pipelines. And so it just really allows you to reuse these modules wherever you want, between pipelines, within pipelines, sub workflows, and however you want. So if you want to see how it's done in the real world, definitely come and have a look. And also, you know, if you want, you can join the community as well, the NF-Core community. Like I said, we're quite tightly integrated with Nextflow as well. So yeah, any feedback, comments, and more contributors is always good. I think that's probably a quick stop shop.
Yeah, cool. Thanks a lot, Ashil. Absolutely. There's a question, one quick question around how do you do version control for your modules?
Let me show again. So version control is done, but like I said, via this modules.json. So if we look at that, each module has a git commit or a hash associated with it. And so that's what this NF-Core tools package does. Essentially, it queries the GitHub API and it sees what commit hash it is. So we can update this hash, and every module that I've got in this pipeline is actually used in the pandemic, this via recon pipeline all over the world to track the evolution of SARS-CoV-2, so genomic surveillance pipeline. But everything is tracked via this git SHA. And so if I wanted to update a module, then this essentially just gets updated directly. And that's how we use the version control in the pipeline.
Awesome, thanks a lot. Yeah, it kind of shows a lot, shows what's possible in terms of building this out, and you know, many different ways that you can arrange these things together for doing this. I was wanted to show you before, I think I had an error. There's a question around how to resolve that. So basically, we were going back. We have this way where we've included this this process from this other file. So here I've got split.nf. So this is a process. I'm importing it, I'm including it from here. And then I can run my workflow here. I'm giving it two different names. So I can either, hey, my pipeline 2. And then when I run this, I can use this entry to determine exactly which workflow I run. So I can run here entry on my pipeline 2 here, and this is going to launch through the second one here. or entry on pipeline 1. Now, when you see this, you'll see one thing that's slightly different is that now we are running a workflow. And inside of that workflow, we have the actual process name. So you'll see in terms of the name of the task that we've run now, it's been prefixed with the workflow. And this is important if you imagine if you have multiple different workflows that are calling workflows, you kind of want to know the path of where that individual task is running. Otherwise, you may kind of lose exactly how it's being called. So this is a kind of quick prefix on that. So now let's go into a practical example of this. And I want to go back to the original RNA-seq pipeline that we developed. And I'm just going to take one of these scripts. It doesn't matter too much. I think we can probably take something like script number 6 or script number 5, one of these, where we've got a few processes that we're going to split out. So in this case, just go back to remind you, we had the index step, we had the quantification step, and we had the FastQC step. And now let's try and think of a way that we can modularize this and we can kind of convert this into DSL2. Well, the start of this pipeline bit can stay exactly the same. All of this can remain in here. And what I'm going to do is I'm going to just export, though, the individual processes themselves, and they're going to be defined outside of this file. So let's create a file here, and we're going to create this new one, which we're going to call our modules. So our modules for our pipeline, so our modules.nf file here. Now inside of this modules, we're going to paste the actual processes. So go back to script number 5, and I'm going to say, okay, you can keep all the marked out down here. So in this case, the first process we have here, take the second process here, the quantification, and then we can take the third process here. You can also follow this along in the RNA-seq pipeline that we have and we placed on GitHub. Maybe someone can post a link to it. You'll find the full example of this if you want to go through this later on and do this. So we've got our 3 processes inside here. And the first thing that we are going to do is we're going to remove the channels section, essentially the into and the from. So when we do this, we can say in the index one here, we actually just want a path, which is transcriptome. We can remove that. We want to say remove the into index step, and everything else can remain the same. I believe I've got this twice here. Okay, and then the same thing for this. So remove the from, remove the into from that. Now we've got FastQC, we've got index, and we're missing one. So let's have a look. We've got here, I think it's quantification. Okay, copy that and paste that in there. So index, quantification, and again here I'm just going to remove from and into. Now what we want to do is we want to import these or include these into our script. So the way that we can do that is in the original script section. I can remove all of this now and remove all of this, remove this section here, remove all the processes that we've done, and going to keep this section here. Now, when we want to include this, we want to use this include definition. So we can say, include our modules here. You can do this at the top. You can do this wherever. Really kind of depends on how you want to do this. And we're going to say include, and we can define the names of the processes themselves. So in our case, we have index, quantification, and FastQC. So we want to say include index, quantification, and FastQC here, import that there. And then the next part we want to do is now we want to link these things together. So we want to write that, main section, that main workflow section as well. Keep in mind, you also have to include this DSL2 bit. So this is here. So we're going to enable DSL2. We are including our modules themselves here. And I think it may actually be a comma. I'm not sure if it's always get confused if it's a comma or semicolon in terms of that. So I'll just have a quick look. Documentation here on the exact syntax. So this is on the modules here, module include. And okay, semicolon is correct. Okay, so now we've included our 3 files. We have to say where we're taking them from. So we're taking them from our modules in F file we've just created. Save that there. And now we can get to the point where we're going to run the workflow itself. So what I typically will see is this. You'll see that the workflow section will start like this. We can define it. And inside here, you can import your channels. Just going to move these over so it looks a little bit nicer. So we're creating a channel. We no longer need this because it's DSL2. So this can be removed here. And we've created this channel, read channel. Again, this is exactly the same syntax as saying read pairs channels equals that. So we've created the channel. And now we've defined for the reads themselves. Now we want to define the actual processes that we're going to run here. So in the exact same way, we can just use this and say we can just reference the index. So going back to this, we can say, okay, we want to define the index, which takes as an input the transcript. So this runs in here, and we say index here, and then we reference the input that we have. If we remember that is our params.transcript file. Okay. I'll let you try and have a look at this. And if you get stuck on this, try and compare it here to RNA-seq NF and Nextflow. So this is this one here. And we've got two versions of this, so you can kind of see the difference between them. If you go back and you see the version 2.0, this tag here, you can go back and compare, see what basically it looked like previously. If you want to see the DSL2 version, you can see here. And what we're building up to is very minimal version. So everything is the same. You'll be familiar with all of this. We include our modules, we define the workflow, and then we run the pipeline. There's one thing to point out here is that this RNA-seq is actually calling a workflow itself. So this is all defined inside of the modules directory here. And this is where you'll find the individual steps like this. So that's the kind of example on that.